which is from AD Academy. In my previous video in this playlist I have talked about activation function, and in the second part of that I have talked about different types of activation function. In this video I will talk about different types of activation function in details, their mathematical formula, how we derive those things, and the application with advantage and disadvantage. My name is Dr. Ayan Debnath. I have secured Ph.D. degree from IIT Delhi in data science. As a visiting research scholar, I also have research experience in Harvard University and University of Pennsylvania. Total 8+ years of experience I have in this field of data science. So let's watch this video till the end to know about different types of activation function with mathematics in depth. Next one is tanh or hyperbolic function. This is the graph of this function, which states that for more positive values of x, output will be nearly equivalent to 1, or for more negative values of x, output is equivalent to -1. Here we can give input any real value, but output will range between -1 and 1. If there is any value which is very positive, then we will map it to +1, and any value which is negative, then we will map it to -1. Now coming to the advantage of hyperbolic activation function. First of all, we can see that the value of the output will centered between 0, like it is centered around 0, so the output can be mapped as strongly positive or strongly negative or neutral. And as the output is centered around 0, it helps to make the learning very faster. The neural network can learn very easily. That is, it is computationally easy. With respect to sigmoid function. Here we can say one important thing is that tanh is better than sigmoid, in a sense that in sigmoid the data is not centered around 0, but in case of tanh the data is centered around 0, and as a result tanh can be used in hidden layers of the neural network, and it is better, like people use tanh more than like sigmoid. This covers the advantage. Now coming to disadvantage, first of all I would like to explain the derivative of this function. If we take the derivative first, we'll see how the derivative looks like. While doing the backpropagation, we need to update our weight. This is a very gold standard, you must remember this thing. This is very gold standard, you have to remember this thing always. Now what happens here is that due to this chain rule, as the value if the value goes beyond 3 and if the value goes beyond -3, then the derivative of the function will be nearly 0. And since the value lies between 0 to 1, so even if for x lying between -3 to +3, the value will be something very small. And as a result, in this chain rule, what will happen if some values come like this? For other case of weight, maybe it can come like this, and as a result this will become very small number. And similarly, as I have explained earlier, this will lead to vanishing gradient problem. Vanishing gradient problem, which is one of the disadvantage. Now let us understand ReLU. ReLU is rectified linear unit, or we can also mention it as ramp function. This is analogous to half-wave rectification in electrical engineering. Now let's understand the mathematical formula and the graph of it. We can mention it as f of x is equals to x for all values of x greater than 0, but it is equals to 0 when x is less than 0, or we can also write it as f of x equals to max of 0 comma x. When we are using ReLU in neural network as an activation function, then in case of backpropagation, what happens is that we have to find the derivative of this function. Now let us understand what the derivative will be. So derivative of this function when x is greater than 0. So what will happen? Now derivative of x with respect to derivative of x will give you a constant value. So derivative will be like this, and when it is less than 0 x is, then the derivative will be like this, right? So what happens is that when we are updating our weight, like w of nu so in this chain rule, what happens is that when we are taking the derivative, so some value will come as 1 and like this. So what will happen, that weight, new weight will be updated because there will be some value. Since the derivative is 1, so it means that it will not go to 0, or it will not make any small number. If it is less than 1, then it will be small number, and multiplied with another small number will give you a very small number. But in this case, like, it is 1. So as a result, there will be some value here, and thus this weight, the new weight, will be updated because this is w old minus some number, there will be some number. So the new weight is not equivalent to the w old, and as a result, weight updation will occur. So updation of weight will occur, and thus as a result it solves this vanishing gradient problem. As I have already explained that in case of sigmoid and tan H, we have seen that this vanishing gradient problem occurs, and it is a very favorite question of interviewer is that what is vanishing gradient problem, when it happens, and how we can solve these things. So we can easily explain that when we are using ReLU, then in this case it resolves this vanishing gradient problem. ReLU is mostly used in case of hidden layers, like we can use this ReLU in hidden layers, and it has some advantage. First of all, it is computationally very effective. Why we can say it is computationally very effective? Because this is a kind of linear function when x is greater than 0, and it is 0 when it doesn't involve any exponential operation, and as a result it is computationally very effective. And as I have already mentioned, that it solves this vanishing gradient problem, so it is one of the very big advantage. And third is that it accelerates the convergence of the gradient descent towards attaining the global minima. Now coming to disadvantage, it has one very disadvantage. First of all, understand why this happens, because when we are taking the derivative, in one side it is 1, another side it is 0. So during this weight updation, we are doing this chain rule here. So as a result, what happens is that when the value of x is less than 0, then it might happen that in some cases it comes as 0. Then whatever will be the value, this will give you 0. And as a result, w of new equals to w of old, and thus no updation of weight takes place. And thus in this scenario we call it as dying ReLU or dead neuron. This is a disadvantage. Now you may ask one question, that I am explaining it as a disadvantage, and again in advantage I am saying that it solves this vanishing gradient problem. So let us understand that when x is greater than 0, then in this case, since the derivative is 1, so as a result here we will get 1, and thus there will be some value weight updation will take place. And when x is less than 0, so in this case in the chain rule we can get 0, and as a result no updation of the weight takes place, and thus in that case only we are saying it as a dying ReLU. Next one is leaky ReLU. It solves the problem of dying ReLU. How it happens is that we can mention it as that in mathematical formula, this is equals to x when x is greater than 0, and this is equals to 0.1 of x when x is less than 0, or we can also write it as max of 0.1x and x. So here in ReLU, like it is when x is less than 0, it is a straight line, but here we are giving like straight line parallel to 0, and here we are giving x as, and here we are giving. So how it solves this dying ReLU problem is that in this negative direction it has some values, and as a result what happens is that when we are taking the derivative of this function in this region it will be like this, but in this region like it will be a constant, because derivative of 0.1 of x divided by derivative of this, it will give you some value, it is a constant value. Thus while we are doing this updation of weight in this chain rule, we will get some value, and as a result there will be an updation of the weight minus some value. So updation of weight takes place even when x is greater than 0 and when x is less than 0. In both the cases it takes place. Thus it solves this ReLU problem or dying ReLU problem. Thus it is a very good advantage. Solves dying neuron or ReLU problem. And what happens that since the value is 0.1x, so while we are taking the gradient in this minus x direction, then it will have some value, and as a result it will take more computation time. The neural network will take more time. So time consumption will be more, which is a disadvantage.